Assalamu alaikum, this is MATLAB course lecture number 6, exercise number 3. The Taylor series for cosine x is given by cosine of x equal 1 minus x to the power 2 divided by 2 factorial plus x to the power 4 divided by 4 factorial minus plus minus plus minus plus etc. Write a continuous running script. Okay, so let us copy this code here from here, Ctrl C. Now I will start a new script file, clc clear close all, write continuous running program. So surely while one, we can solve it from the beginning like this, but I will make it continuous at the end of the program, at the end of the solution. Now write continuous program. Prompt user for the angle x. So we can write x equal input. Okay, please enter the angle as example in degrees. Please, it should be a string, so just don't forget quotations. Please enter the angle x in rad in degrees. Okay, then go to the next line. I don't want to see the result in the command window. Using loops and anonymous function, compute the estimate for cosine and output the estimate with 5 places behind the decimal point and output it. So we have to calculate the estimate. How? Later. The computation should stop if number of terms used for Taylor series estimate reach 200 or absolute difference between the estimate and the actual is this value, 0.0001. So to calculate the estimate, let us talk about the estimate value, guys, before. As you see here, it is cosine equal 1 minus x to the power 2 divided by 2 factorial, plus, not minus, x to the power 4. So we have plus, minus, negative, positive. The first term, it is 1. For the second term, x to the power 2. The first one, x to the power 0. The second term, x to the power 2. X to the power 4. So all of the power values, they are even numbers. The first question, it says that we need 200 terms. But we have even numbers, 2, 4, 6, 8. To make 200 terms, the last power, it should be around 400. Because here we have 2, 4, 6, 8. So 400 divided by 2 give you 200 terms. So we have to write a loop. Here. We have to write a loop. This loop should start from, say that 0 or 2. It's up to you. Let us start from 0. Okay, I solved it for the previous section number 1. Start from 2, but I can start it also from 0 here. So what I will do, guys, I will define the value of the cosine. Say that estimate, say that e, or estimate, or e equal, at the beginning it is equal to 0. Now we have to use a for loop as example. Say that I have a counter, name is I, equal to the start point, it is the counter 0, and it will go to 400, okay, incremented by 2. Why 400, not 200? Because if it is incremented by 1, right here 200, but we incremented by 2. To get 200 terms, we have to continue to 400. Why I want I to be even numbers? Because the power in the cosine estimate here, it is even numbers also. It is even number. So this is the for loop. This is the end of the for loop. Now what is the value of e here? The estimate equal the previous estimate plus the current term. What is the current term? It is as example, when it's 1, it means x to the power 0 divided by 0 factorial. When I equal 2, it is x to the power 2 divided by 2 factorial. So we can write here, it is e plus the x value x value to the power of I divided by factorial of I value. Okay, and we can say that this is just between brackets like this. Okay, the problem here, guys, it is not positive always, not addition always. For the first term, it is positive. Second term will be negative, then positive, then negative, then positive, then negative. So let us say that we want to multiply this value by -1 to the power something. If I wrote I here, I it's always even. And you know that when you take the -1 to power of even number, the final result will be 1 always positive. I will get the same, so it will not change. So let me use another counter, say j, and start j, my counter starts from 1. So when I equal to 0, j equal to 1. 1 minus 1 to the power of 1, it will be -1. So I prefer to start from 2. Now when I equal to 0, j start by 2. -1 to the power of 2, it will be positive. It will give me 1 positive. Why 1? Because x here to the power of 0, it will be 1. Divided by factorial of 0, it is 1 also. So the result, this one, it is 1. 1 multiplied by 1, it will be positive. Now what, after calculating the estimate here, and before go to next I, we have to say j equal j plus 1. Why j plus 1? Because again, at the beginning, j equal to 2. When I equal to 1, j equal to 2. This will be positive. Now I will become 2 because increment by 2. J value will become 3. So here, guys, we have -1 to the power 3. It is negative. So all of this term will become negative as we see in the equation here. So I used another counter. Why? Because this counter not incremented by 1. I used j, another counter increment by 1 to just get the value, sometimes positive, sometimes negative. Now, this is the value of the E. When we should stop this loop? We should stop loop when we reach the term number 200, which is when the I value equal 400, or the estimate difference between the estimate and the actual less than 10 to the power minus 5. So we can write here f, this is the end of the f, if the absolute value, the difference between the estimate minus the actual A, but the actual value should be declared before. So read the value of x and find the actual. Actual equal cosine of x. Remember that x here in degrees. So write cosine d. Okay? Now, absolute value, if the absolute value of the estimate minus the actual become less than or equal to 0.0001, if this is true, what should I do? Break the loop and print the result. When you break the loop, it will go to here. Now we have to print the result. So we can say that f print f. We can say that the estimate of the cosine at the value of x, which is a float, equal to this value, which is a float. Go to next line. The first value, it is the x value in degrees. The second value, it is the value of estimate E. Not wanted like this, but I'll just for now. Now save the program. .m. Run the program. We have a problem here in line number 15. What's the problem? When calling function invalid variable. What this invalid variable? X, it is x here, and E, it is the E here. %f equal %f. Save the program, run again, same error. In line number 9, sorry, column number 15, line number 9, e equal e plus minus 1 to the power of j, it's equal to 2. Yes, here, multiply by x to the power of I. Now it's okay. Run the program. Please, 45, cosine of 45, not a number. Why not a number? Why not a number? X in degrees, but in the equation here, it should be in radian. So read the x value, calculate the actual, then say that x equal, to convert from degrees to radian, x equal the previous x, multiply by 314 divided by 180 to convert it to radian. Now run the program again. Please enter 45 as example. The estimate value of cosine at 0.7, which is the x. So here, let me convert it back to degrees better. So multiply by 180 divided by 314 like this, better. Run the program again. This is 45. See, the estimate of the cosine at 45 angle equal minus 1.3. Minus 1.3, it's not correct, by the way. Not correct, by the way. What is the mistake here? We started the estimate from 0. It's okay. When I equal to 0, x to the power of 0 will be 1, divided by factorial of 0 is 1. Let me check. Factorial of 0. Yes, it is 1. So and now when I equal to 0, j starts from 2. Now minus 1 to the power of 2, it will be 1. So the first term, it will be positive. Very good. Now next, I equal to 2. J, it will be equal to 3. J, it will be equal to 3. Minus 1 to the power 3, it will be negative. The second term negative. Then j equal 4. 4, it will be positive. Correct. We don't have problem here. We don't have any problem. Why we got this value? I don't know. Let me repeat again. This is 45. Okay, 45. Yes. I don't know why. Okay, guys, let me continue the program. I will see where is the mistake later. Okay, where is the mistake? Next step, guys. Now, as a program, it is done, but we have to print out the estimate. As you see, the angle and number of iterations to get the correct answer, the estimate Taylor series, and the actual value in a table like this for 10 times, 10 rows. To simplify it, guys, I will do it for 5 times. So as you see, all of these should be inside a loop. So cut this loop. Okay, cut this loop. Right, while we need a counter for this while. Say the counter value, it's k started from 1, as you see here. Okay, and while k less than or equal, it's supposed to be 10, but I will write 5. Okay, and then I will paste the code like this. This is how we can write a while loop running 5 times. Okay, I will paste all of these and align them together like this. This is inside the for loop. This is for f. This is for f. This is for the for loop, and this one aligned with the for loop inside for the while. Okay. Now the loop should run 5 times. Now each time I'm running this loop, guys, see. The value of j, because j started from 2, remember that, j started from 2. I started the j from 2. So let me, I have an idea. If I started j from 0, what will happen for the first one? Minus 1 to the power 0 will be what? Will be 1. That means it will give me a positive. When j equal 1, it will be negative. So I will start from 0. It will not change the result. Okay. J start from 0, guys. That means the last j here, guys, before the break, it will represent how many iterations this loop run. So number of iterations for this loop, actually j represent number of iterations, not I because incremented by 2, while j incremented by 1. So we can say that as example, we can actually no need to print this one, but let me delete it later. I can say iterations itr when k equal to the value of current k equal the j value. So what I'm doing now, for the first, see, when k equal to 1, I will ask user to enter the first angle, find the estimate and number of iterations, then save number iterations in the first as a first element in the itr vector. So it depends on the value of k. And I will do the same for the estimate value and the actual value. Say write actual of k equal the actual value, which is a. Why? Because for next angle the actual value will be related to the previous actual. So I will hold them, keep them in a vector called actual. And same thing for the estimate, est of k. Say that I'm declaring a new vector called estimate, est equal the e. So when k equal to 1, I'm reading the first angle, calculating the actual cosine for that angle, calculating the estimate and number of iterations. Number of iterations for the first angle will be saved in iteration of k is 1. The actual for k equal saved in the first element of actual of k, and same thing for the estimate. So I'm declaring 3 different variables or vectors. And same thing for the x itself. The x itself, we can write angles a and g, angles of k equal x in degrees. So the first x will be in the first element of a and g. The first j will be in the first element of iteration vector, and so on. So why I'm doing that? Because I want to print them like this in a table. So I have to hold them. Now, after finishing this loop, guys, I will cut this code. I will go outside the loop. I want to print them in table. We have different options. You can use table to matrix to table. You can use fprintf. You can use for loop. I prefer to use for loop, guys. So I will use for loop. Say start k equal to 1 to 5. It should be 10, but to 5, incremented by 1. So because the increment is by default is 1, no need to write 1. This is the end. What I will do in this loop, I will print. But before that, let me print. Say that I want to print a message, represent the title of the table. So all of this should be deleted, and this one should be deleted like this. The message is the title of the table. Control C, Control V. Then go to next line like this. Estimate versus whatever. Okay. And next, guys, I will print the column titles. So I will Control C, Control V, and remove this one. Okay, I will print these titles. So like this. But let me make the MATLAB larger like this, guys. Okay. So angle, no need for x, just angle. Then followed by spaces. Number of terms, spaces, we can write estimate, spaces, actual, just to simplify it. Okay, so we have enough spaces here. Good. Now next step, I want to print the values. So I want to print f. Okay, I will print at the beginning, we want to print a float number, represent the angle in degrees, so that we can say that it is 0.2 float, 3, 4, 5 spaces, 6 spaces as example. So instead of that, what I will do, I will write here -6. That means reserve 6 spaces and put the number to the left of these spaces with 2 decimal places only. So keep just 1 space here. For the second one, same, guys. The second one represent, as you see in the table, number of iterations. It should be integer. Number of iterations should be integer. So write here minus 6d. Next one, it is estimate value. It is a float. It is a float. And final value, it's the actual value. Say that it's a float. From where I will get the first one, it depends on the k value. So the first one represents the angle itself, which is A and G. It depends on the k value. When k equal 1, printing the first angle, k equal 2, second angle, and so on. Number of iterations, it's ITR of k, same. And third one, it will be estimate. It is EST of k. And the last value, guys, it is the actual, which is ACT of k. Let me save the program, run the program. Please enter, say that angle, first angle 45, 90, 135, 180, 225. And also say that 260 as example. Why never stop? It should stop. Do you know why? Because now it's running infinitely, because the k value not incremented. So I will Control C, abort it, and go to here. Before the end of the while loop here, write k equal k plus 1. Because k, it's always 1, it will run for infinity. Again, right here, it is 45, 90, 135, 180, 225, the last one. See the estimate, but I forgot something. I forgot to go to next line. So print here and then go to next line before. Okay, so again, save, run the program, say that it is 45 again, 90, 135, 180, 225, done. See, but we have to change the spaces only. Keep not 6 spaces. I think it's 10 better. Use this one for 10. I think 10 is better than 6. This is will be 10. This is will be 10 also, and this is will be 10 also. Run the program again. This is 45, 90, 135, 180, 225. For the first and second one, it's good, but the last two, maybe we have to write 15 better. 15 here, 15 here, it's okay. Run the program again, write 45, 90, 135, 180, 225. We need also, okay guys, now I just fixed the spaces, and I found that the mistake is here, because if I run the program now, we got wrong answers for the estimate. Why? Because this one should be between two brackets like this, so minus 1 to the power of j. Now save the program, run it again. Let me run for the first angle is 45, second angle is 90, next angle is 135 as example, next one 180, the last one 225. So I see the estimate. This is the title, this is each column title, and these are the values. I see the estimate and the actual, they are same, approximately same using this algorithm. And see, we got the angle, but the angle here should be changed. We should get the angle back to the degrees. So how we can do that? Set the angle equal x multiply by 180 divided by 3.414 to get it back to degrees before printing it, or save it in the angle vector. So run the program now. Again, 45, 90. Say that 135, say that 180, say 225. I see the angle 45, 90, number of iterations, estimate value. For 180, we need just seven iterations. I don't know why, but for the others, we need 2 and 1. Actually, it should not be 2 and 1, because number of terms should be maximum 200. That means, why? Because we started, if you remember, we started here j from 0. Okay, so we can at the end here write iteration number of iteration of k equal j plus 1, because when in the first iteration j will be 0, it should be 1, like this. like this. But when okay, let me again, when say that this condition is true, the last j is correct. So let me try now. Run the program. Please enter angle 45, 90, 135, 180, 225. Number of iterations increased by 2. I don't know why. So to make it we can write j minus 1 better. J minus 1 better. Run the program. Angle, say that 45, 90, 135, and here 180, 225. The number of j is maximum 200, but I think this is there is a mistake here. We should not write j minus 1 because the last j, when j equal to 0, the last j, no, it's okay. No, it's okay, because when the last j, when break it happen, well, I don't know. When it happened, this one happened break, the last j is valid. It should be +1, not -1. Maybe because we started the I from 0. Anyway, this one, the maximum number of terms should be 200. See, for the first angle, the condition we didn't reach this difference, but we reached the term number 200. For the angle 180, we reached the value or the difference between them within this range after just 6 iterations. After this, just this 6 iterations. But still, I think this is not doesn't make sense to say that j minus 1. I don't know. There is something here, but yes, the maximum reach should be 200. So it's correct now. So we finished the classwork number 3. We wrote it continuous running program, and we should stop at 10, or we have to go to here. We have to go to here, change it from k equal or less than 5 to 10 to make it like what in the exercise, and this should be 10. That's it. Thank you so much. See you in next video. Now we can print the result in different way. No need for the for loop if you wish, but I prefer the for loop because I want to print one by one to control everything. So we can define a matrix, a new matrix. Say that my matrix M, the first as you see here, the angle in the first column. That's right. So the first, we can say that all of elements in the first column equal to what? Equal to the angles. The vector, it's A and G. We can say that my matrix, or the matrix, I want all of the rows in the second column to be equal to, as you see in the table here, number of iterations. So ITR vector, and we can write M, all of rows in the third column equal to the estimate, which is the EST vector. And we can write M of all of rows in the fourth column equal to the actual ACT. And then we can write display the values of M. And let me go back, just keep this one and keep this one, and surely we have to go back and fix the spaces. So let me run the program, but let me run the program for 5, just to for simplicity, write k equal 5. Okay, run the program. Okay, say that 45, 90, 135, 180, 225. See, angle. Okay, but we have to just do what? Fix the spaces. We have to move the angle, as you see, move the angle 1, 2, 3, 4. Say that 5 spaces. Number of terms will be okay, I think, but we decrease this distance. I don't know. We have to fix the spaces in a good way. We can also use matrix to table. to print out. We have many methods to or ways to print the output. Thank you so much. See you in next video.